Now we want to continue with our substitution. And this next one's pretty straightforward. This one, r equals cosine theta, r equals 1 minus cosine theta. Let's plug cosine theta in for r every place we have an r in the second equation. So we'll have the cosine of theta equals 1 minus the cosine of theta. 2 cosine theta is equal to 1. Cosine of theta is 1/2. And this looks pretty familiar to what we just did before. The arc cosine theta is 1/2. So theta is equal to 5 pi over 3 and pi over 3. And then I can go and plug into one of my original equations. R equals cosine of 5 pi over 3, and r equals the cosine of pi over 3. And we see here that r is going to be 1/2. So my ordered pair for this equation is going to be 1/2, comma 5 pi over 3, and 1/2, comma pi over 3. Seems pretty straightforward. But let's check our answers graphically. R equals cosine of theta. That we know is a circle with diameter 1 along the x-axis. 1 minus cosine of theta. Remember, that's 1 minus 1 cosine of theta. So the minus cosine of theta here portion is a reflection to the other side of the y-axis, or the theta equals pi over 2 line. And then we've got a 1 minus 1 here. That's a ratio of 1 to 1, which produces a cardioid. So I'm going to have the general shape that looks like that. So I can see there's one point of intersection. There's my 1/2 comma pi over 3. Down here, there's my other point of intersection, the 1/2 comma 5 pi over 3. But if I look at this graphically, I appear to have a third solution right at 0, 0. And I actually do have a third answer at 0, 0. But I didn't get that one the same way when I substituted. I sort of had to use my graphical reasoning to come up with that 0, 0. And so that's one of the issues that we're going to run into as we solve these polar graphs. The first two came up with no problem, but the third one didn't. Now, as we look at that, why is that the case? And what was the issue we ran into? Well, we noticed we didn't get all solutions. We were missing that point 0, 0, or we were missing the pole. And why is this the case? Well, there's multiple ways to write a point in polar coordinates. And so even though they're identical points, the r thetas look different. And you know, to solve an equation that in rectangular, the xy that you plugged in had to work with every equation. Same thing here. Your r theta you plug in has to work for every equation, but the exact same point, if I write a certain way, might not work in one equation, but it works in the other. For example, with this previous one, I started out with r equals cosine of theta. And if I plug in r equaling 0, that occurs when theta is equal to pi over 2. So this one right here, r equals pi, or excuse me, cosine equals pi over, or cosine of pi over 2, that's what gives us my r of 0. This right here, the ordered pair, 0 comma pi over 2, if I look at that picture, that means I'm going to pi over 2, I'm facing in this direction, and then I'm going 0 units up, which is still the ordered pair, 0 pi over 2, a way to write the pole. However, if I use the equation 1 minus the cosine of theta, and if I were to try and plug in 0 pi over 2 for this one, I would get 0 equals 1 minus the cosine of pi over 2. And the cosine of pi over 2 is 0. So 0 equals 1 minus 0. 1 equals 0. I can't plug this 0 comma pi over 2 in and get the solution to the second equation. Rather, what I've got here is that when r is equal to 0, theta has to equal 0. So 1 minus the cosine of 0. So then 0 equals 1 minus 1. So 0 equals 0. So this is the ordered pair that solves that equation, even though 0, 0 and 0 pi over 2 are the exact same point here. Depending on that angle measurement, it might work in one equation and it might not work in the other. That's one of the issues we have with polar coordinates. So how can I be sure that I can get all solutions? And what I can do is convert to rectangular coordinates and solve. Now we just found out on the previous page that I had the cardioid here, I had the circle there, and I had an intersection there, and intersection there. Can I come up with 3 intersection points if I do this in rectangular? So let's convert. R equals cosine of theta and r equals 1 minus cosine of theta are the 2 equations I had. We'll start by multiplying through by an r. So r squared is equal to r cosine theta. The second one, r squared equals r minus r cosine theta. And then we'll plug in what we know. We know r squared is the same thing as x squared plus y squared, and we know r cosine theta is the same thing as x. In my second equation, r squared is the same thing as x squared plus y squared. R is the same thing as the square root of x squared plus y squared. And then minus r cosine theta is the same thing as x. So now I've got a system of equations that's x squared plus y squared is equal to x, and x squared plus y squared is equal to the square root of x squared plus y squared minus x. So just as we did before, I'm going to substitute in. Here I see x squared plus y squared is equal to x. So in my second equation, wherever I have an x squared plus y squared, I'm going to replace it with x. So here, x is going to equal the square root of x minus x. And we'll go through and solve this algebraically. We'll add x to both sides. We'll square both sides. We'll subtract the x to the other side. And now we've got an equation that's equal to 0. That's the same way we always solve. We can factor out an x and set each piece equal to 0. So I have 0 and x is equal to 1/4. These are my x coordinates. So I get x equals 0, x equals 1/4. So what I've got to do now is plug that into one of my original equations. And the easier one to plug into is going to be the first one. So x squared plus y squared is equal to x. X squared plus y squared is equal to x. So I'm going to plug in both of these x values to find their corresponding y values. So if x is equal to 0, 0 plus y squared is equal to 0. Y squared is equal to 0. So y equals 0. There's the ordered pair 0, 0 that I get from the very center that I wasn't able to find in polar coordinates. Let's go with the other one. If I plug in 1/4 quantity squared plus y squared is equal to 1/4. 1/4 squared is 1/16. We'll subtract the 1/16 to the other side. So then y squared is equal to 3/16. And then we take the square root to both sides, and we get plus or minus the square root of 3/4. So since I plugged in 1/4, I get a y value of plus or minus square root of 3/4. So one ordered pair is 1/4 square root of 3 over 4. The other ordered pair is 1/4, comma, negative square root of 3 over 4. So there's all three ordered pairs that I get that are there on the polar graph. These are the rectangular equivalents of those points. And the reason why that works in rectangulars, there's only one unique way to write a rectangular coordinate, whereas in polar coordinates, there's multiple correct ways to write a polar point.